Okay, we're getting started. Welcome back to day 5 of data analysis and web development in RShiny. So far in the course, we've gone through the basics of computer science and coding in R. And then we took a look at how to implement a user interface using RShiny. And then yesterday, we looked at some functions that help you analyze bigger data sets. And today we'll be wrapping up our mini series with a short introduction to data visualization. So I'm going to share my screen here. Okay, so today we're going to be talking about data visualization. So what exactly is data visualization? It sounds like a complicated term if you've never heard about it before, but I'm sure if you've encountered these concepts in many other classes, including math and science. So basically, what data visualization is taking our data sets and the statistics we calculate on the data sets as we did yesterday, and representing them visually using graphs. Okay, so the first thing we're going to do is draw a new plot or an empty graph in R using the plot function. And the plot function takes in many arguments to specify which type of plot you want. So first, on the plot or on the graph, first you specify x, and y. And x and y are the coordinates of the points that you want to plot on your graph. In this case, I'm creating just a new empty blank plot. So I'm not going to be specifying any points for now. And then we want to specify some limits. In this case, I'm going to span my plot from 0 to 10 in the x direction and the y direction. And this might seem a little confusing now, but I'll be representing all this code visually in the plot, as you can see in RStudio on the bottom right under plots. So when you run this function, it automatically renders a plot to this plot window right here. Okay, so this is the most basic kind of plot. So we specified x values and the y values of the coordinates of points that we want on our plot. But we don't have any points, so we specify as null. And then the limits are 0 to 10 in both directions. And then some other things we can specify in our plot are access labels. So we can say xlab equals x, and ylab equals y. Okay, and then now when we run this code, notice that it also renders access labels on this plot. We can also write a title using the main parameter, main equals title. Okay, and now we see we have a title here. And some other things that are important to include in every plot are ASP, which stands for aspect ratio, which basically ensures that the plot is of standard size. So when you increase or decrease this window, if you set the aspect ratio to 1, it automatically resizes your window correctly and plots your points proportionally to the axis. And then we can also specify whether we want whether we actually want axes or not. So if we set axis equals false, this will generate an empty plot without axes. In this case, we want axes. Okay, so now I just tell you how to create a blank plot, but that's pretty boring, right? Because we want to be able to visualize our data, so we want to add things to this plot. And on a scatter plot, as you may know, we add points that represent data in real life. So we can add points, we can add lines, we can add text, and a whole bunch of other things. But these are the main elements of a graph or a plot. Okay, so now I'm going to generate some random points, x and y, and these vectors are going to specify the x coordinates. This is going to specify the x coordinates and the corresponding y coordinates of the points we want to plot. So our plots the points a little bit differently in that you specify all the x coordinates and all the y coordinates separately. But what it does is it's going to plot each corresponding element in the vectors. Okay, so now to add points to our plot, we're going to specify the use of. Oops. One sec. Oh, did my screen go blank?
No, you're good.
Okay, sorry, I'm using an external display monitor, so it just disconnected. But now you should see the template back. Okay, so where were we? So I just drew a blank plot, and now we're going to specify some points. So here are the x coordinates of the points, here are the y coordinates of the points. And now we're going to draw points onto the graph by using the points function. And into the points function, we're going to first specify the x coordinates of the points we want to create, the y coordinates of the points we want to create. And that's all that's necessary for creating points. Yeah, so now we have the points here. Actually, I'm going to change the axes so that you can actually see these points. Okay, so points. Okay, so now we plotted our points here. And these are the default points that are rendered in our plots. But like other functions, you can add many more parameters to make these points look more interesting. So first we can change the color by using col. Parameter. And this changes the colors to blue. And notice, actually, I'm going to copy this line of code right here. So notice when I run this command, what it actually does is it draws a set of points on top of the existing points. So when I'm drawing lines, it's going to draw them on top of these points. So actually, yeah. So if even when I change these, if I change the set of points, and I run this line, it's just going to overwrite points over this line. It's not going to delete the previous points that we've drawn. So to delete the points that we didn't want, so in this example, there's actually a set of black points and a set of blue points over it. So if we want to delete the original set of points that we didn't want, we just have to rerun the all the lines of code that generate the graph elements that came before. So when I'm going to be demonstrating these functions, I'm also going to be running this line of code here to reinitialize the plot and then draw the elements on top. Okay, so other parameters we can specify are, let's see, the size of the points. with CEX. So the default value is CEX equals 1. And this is represents the magnitude by which you want to increase or decrease the size of the points. So we say CEX equals 2. It'll make these points twice as big, and we set CEX equals 0.5. It will set the points to be half the size of the original size it was before. Okay, and another parameter we can specify is PCH. I'm not sure what PCH stands for and why these specific values correspond to it, but PCH tells you the type of points that you want, and they're specified by different numbers. So for example, PCH 20 specifies solid points. So you notice that before the default was hollow points, PCH equals 20 specifies hollow points. And if you want to find which PCH corresponds to which type of points, you can run this command here, question mark PCH. I'm going to run this line. And that opens up the help window and searches what the PCH is. So here we see some PCH values. So you can change the style of your points to look like any of these by specifying the PCH value. Okay, so now we're going to go to the plots, back to the plots. Now we're going to draw some lines on top of this. We're going to draw some lines. Okay, so if we specify the command lines, you specify x. The x value is first, this is actually the x coordinates, the vector of x coordinates that we specified, and then the vector containing the y coordinates of the points that we're specifying. What this does is actually just connect the dots. So if you notice here, it looks like it's one smooth continuous curve, but if you look closely, you'll notice that this line function takes in a vector of points specified by the coordinates and draws lines between each of the points, connecting the dots. Okay, and similar to the points, we can specify different parameters, such as color equals blue. I'm going to run all these lines. And now we see a set of blue lines connecting the blue points. Okay, we can also specify the line thickness with LWD, which stands for line width. And similar to CEX, it tells you the magnitude of by how much you want to amplify the thickness. For example, 2 makes them twice as thick. Okay, and then we can also specify the type of lines by the parameter LTY, and LTY2 gives you dotted lines. Okay, we can also draw just plain vertical and horizontal lines with the function AB line. So first, if I want a vertical line, I specify the value at which I want a vertical line, which is say 5, and then say I want to make this a red line. Now we have a red line at 5. I can also draw horizontal lines by saying h equals 5, and that draws a horizontal line at 5, which you can't see because that is outside the bounds. So I'm going to draw a horizontal line at 0, and now you can see a horizontal line at 0. You can also draw straight lines, for example, in the form y equals mx plus b. That's using another function called curve. And in general, you can use other packages to be able to do actual real algebra in R and graph those. but I'm not going to be going over that here. In general, take a look at the function called curve. But next, you can also add some text. So on text, you specify the coordinates of where you want the text to be, say 5, and then the message. And then you can also specify CEX, which is the magnitude of the text. If I want CEX equals 2, I can do here. And now you see it just overwrote text that's twice as big over the old one. Okay. Now I'm going to clear this plot. I'm going to clear this plot by just running the line that it creates a new blank plot. And actually, I'm going to change these axes to 0, 10. Okay, great. And now, next thing we can do is draw segments and arrows. So for example, arrows, we specify the starting coordinate of the arrow and then the ending coordinate of the arrow. For example, if we want the starting point to be 1, 1, we say x0 equals 1, y0 equals 1. And then the second point, we want it to be at 3, 3, we say x1 equals 3, y1 equals 3, and it draws an arrow. And similar to lines, you can specify other parameters such as, let's make this green. And let's make the line width 2, and let's make it dotted. Okay, so now I'm gonna reinitialize the blank plot and draw the new arrow. And now it's a green dotted, super thick arrow starting from the coordinate 1, 1, ending at the coordinate 3, 3. And you can do the same thing with the function segments. It creates a segment without the arrowhead. Okay, so now that's a scatter plot. Now we're going to now I'm going to show you how to draw a bar plot and a histogram. So a bar plot, as you know, represents the data visually using a set of bars. So instead of specifying points on here, it would specify a point and then draw a bar under the point. And a histogram looks similar to a bar graph, but it represents the frequency of elements in the data set. And this will make more sense when I show you visually. Okay, so first I'm going to generate a random set of numbers using the sample function. I sampled 12 numbers from 1 to 100. And I set replacement equals true, which means that it can sample multiple numbers that are the same into here. Okay, so now we're going to draw a bar plot. Well, first I'm going to clear the plot. You can clear the plot with this brush. Yes, clear the plot with brush. Okay, or you can run the command plot.new. It creates a new empty plot. Okay, so now we're going to type in the function bar plot. And then first what we're going to do is specify the height. Okay, so the only thing you actually have to specify is the height, which is gives you the heights of each of the bars. So here was these random set of data that we generated here, 72, 93, so on. And as you see, it was rendered here. We can specify some other parameters. So we can create labels for each of these bars by saying names.arg. And here, for each of the 12 bars, I'm just going to call them the names of the months, which month.name gives you month.name gives you a list of all the names of the months. And now each of the bars is labeled its own month. And you can't see it here because the text doesn't fit. If you increase the size, you'll see more months appear. Okay. And similar to how we were specifying parameters before, we can specify, let's see, with a plot, we can specify labels. X label equals X. Y label equals Y. And we can specify a title. We can specify a title, and then we can also specify the colors of the bars. Color, we make it blue. And then we can specify the borders of the bars. Make it look really fancy. And then we can also say axis equals true. These are just parameters I chose. You can choose your own. There's also more that you can find on the documentation online. Okay. Next, I'm going to draw a histogram of these values. And you'll see the difference between a bar plot and a histogram. Okay, so we can use the function hist. Okay, so the first data, we specify the data we want to draw in a histogram. Okay, and what a histogram does, it tells you the frequency of elements. It plots the frequency of elements that lie between the bars. So in this case, let's generate a new random set. Okay, here's a random set of numbers. I'm going to draw a histogram. Okay, so here it says between 0 and 20, there are 2 numbers, as you can confirm here, and so on. Between 60 and 80, there are 3 numbers, as you can confirm here. Cool. And one specific parameter to a histogram is breaks. So notice how it defaulted the bars between each, the bars by sets of 20. But you can specify your own breaks. So say I wanted to specify, cut off each bar at 10. So I can say 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And now I change the width of the bars so that this histogram represents the frequency of elements that lie between quantiles of 10. So now we can see between 70 and 80, there should be 3 values, as you can confirm here. I think it's inclusive, which means that this bar represents the number value between 71 and 80. Okay, so when we specify the breaks, we wrote all of them in as 0, 10, 20, 30, 40, 50s, and so on. But we can write a shortcut. As you remember, the vector 0, 10 gives you all the values from 0 to 10. So now we can specify this vector by multiplying this by 10. And you do the same result. So you can replace this by 0, 10 times 10. This should give you the same thing. Okay, so now what we're going to do is apply these principles to our coronavirus data set that we found yesterday. So okay, so what I'm going to do is read in the data file containing all the coronavirus information. Exactly the same way as we did yesterday using read.csv. in order to read this file, make sure to go to Session, Set Working Directory, choose Directory, and choose the file in which folder in which your file is contained. And my data set is contained desktop, so I'm going to open the desktop folder, and now I'm going to read in this data. Okay, cool. And now we're going to I'm going to clean this data and create some variables that we're going to plot. Okay, so actually this this data actually contains data from far back, but now I just want the data that's from this year as of January 1st, 2020. It actually contains information from December 31st, 2019. So I'm going to subset the original data set and store it in a new variable called new COVID data. So I'm going to write subset COVID data. And then we're going to subset COVID data subject to the condition that the year equals 2020. Great. Now what I want to do is, okay, so let's take a look at this data set. So now we only have observations from 2020. Okay, so now what I want to do is create a new column that specifies the number of days after January 1st. So notice we're given the day, month, and the day, and the date, but I want to create a new column that specifies the number of days after January 1st. So the number of days after January 1st is we can count that by multiplying the number of months by the number of days in each month, which I'm just going to approximate to is 30. And then we're going to add the days here. So what I'm going to do is I'm going to call this time. I'm going to create a new column called time. And I'm going to say that is this data set. That's the value in the month times 30 plus the number of days after the start of the month. Day. Cool. Okay, and now I'm going to create 5 different data sets, each representing observations from specific countries. So today we're going to be visualizing data from South America. So I'm going to create a new variable called Brazil, and I'm going to subset this new COVID data set, and I'm going to subject to the condition that the countries and territories is called Brazil. Okay, great. I'm going to run that, and then I'm going to write the same thing for 5 other countries in South America. So we're going to create a data set called Colombia, and I'm going to subset the same data subject to the condition that the country is called Colombia. So I'm just going to copy and paste this and replace the country name with Colombia. And then I'm going to do the same with Argentina. Argentina. And then I'm going to do the same with Peru. I'll do the same with Peru. And then finally, I'm going to do the same with Venezuela. Okay, so now I have 5 data sets here, just representing observations from the original data set corresponding to their country. Okay, so now we're going to visualize this data in the following different ways. Okay, so first I'm going to clear the plot with the function plot.new. Okay, so let's see, what are we going to do? We're going to draw a line graph comparing the number of cases in different countries over time. Okay, so first what I'm going to do is plot the number of cases for each day for Brazil. Okay, so what I'm gonna do is I'm gonna plot the X values. On the X-axis, I want the values from Brazil corresponding to time. The Y values, I want to be the number of cases. And here you can see the number of cases. Here we're also going to specify X label equals time, Y label equals cases per day, title equals coronavirus cases. Okay, great, and now updated our labels. And for this one, I'm going to set a color equal to red. And then I think these points look kind of messy, so what I'm going to do is convert these points into lines, and that is type equals quotations L. And that, to me, that looks a lot cleaner. So that represents the number of cases per day over time for Brazil. And now on this plot, I'm going to overwrite this plot with points corresponding to number of cases per day for other countries. And notice I'm not going to initialize a new plot because I want the data from Brazil to still show up. So what I'm going to do is I'm going to call the function points and say X equals Colombia time, Y equals Colombia cases. And this one, the color is going to be orange and the type is going to be L. And I typed points wrong. Great, and that's the number of cases in Colombia. I'm just gonna do one more. Peru. X is a time, Y is the number of cases. Color equals green. And type equals L. And cool, and now you can see country by country comparison of the number of cases in different countries. Okay, so now we're going to move on to drawing a bar graph comparing the average number of cases reported per day in these different countries. Okay, so I'm going to initialize a new plot with plot.new. Okay, so now I'm going to draw a bar plot. And the parameters are going to get too long to fit on one line, so I'm going to put them on multiple lines. Okay, so we're going to specify the height. What do we actually want to show on here? We want to specify the mean of different cases, the mean of the number of cases in different countries. So for example, this bar plot just represents, this one bar so far represents the mean cases in Brazil. And I'm going to add the mean cases in other countries. Let's see, in Colombia. And we're going to add Argentina. And we're going to add Peru. And we're going to add Venezuela. Okay, and now we can see a bar plot representing the average number of cases in different countries. So remember, we want to specify the names of the bars. We type name.arg equals, make sure to have a comma here, names.arg, and the name of the countries. Brazil, Colombia, Argentina, Peru, Venezuela. Okay, and for the sake of time, I'm not going to be fixating on the other parameters. So the last thing we're going to do in this part is we're going to draw a histogram showing the frequency of days in the number of days in Peru with over 1,000 cases reported. So the data we want to show here is the subset of data. So we want the data in Peru. We want the days in Peru. Right, but we want to find the number of days subject to the condition that the cases are over 1,000. So we're going to subset this data, and we're only going to look at the data where the cases were over 1,000. And there you have it. In this histogram, each bar represents a set of 10 days, and this shows you how many days out of those 10 days did Peru report over 1,000 cases. And like before, there are many other parameters you can add, but I'm not going to add that for now because what I'm going to do now is show you how to apply these skills into one final app that we're going to create. Okay, so now I'm going to go over here. Let's clear the plot. Okay, so now what I'm going to do is now we're going to create this graphing app. And I'm going to show you how to draw plots into RShiny. Okay, so you can see my double screen. I'm going to minimize this. I'm going to minimize this. Okay. Okay, so on this app that I just created, actually a few hours ago, you can create your own graph. So you can specify a limit, lower limit, upper limit, and then click create new plot. And then here, you can click on the graph and specify points, and it will tell you the coordinates of the points right here in this data table. So this incorporates, this app might seem kind of useless, but it incorporates several key features of RShiny. So as always, keep a mental note of what this app looks like because I will be creating this from scratch using a template. Now I provided you the code for the whole app. I didn't provide a template because I think it would be too fast to type in here. So if you want to follow along, you can follow along on the final version. Okay. So here we have a blank app. Remember with the header, the sidebar, and the body. Okay, so first what I want to do is set a title of my header, and this one is going to be called Graphing by Lucas. Okay, and the title width, I want to be a little bit bigger, so I'm going to set it to 400 pixels. Okay, sidebar, I do not want a sidebar, so I'm going to set disable equals true. Oh. Right, okay, perfect. Looks like my shiny dashboard is corrupt. Ooh, doesn't look good. Okay, but we're going to create some widgets here. We're going to create some widgets here in the body. So first, we're going to have a text input. Oh, actually, first, we're going to have a title that says graph your function here. Okay. This window was small. Okay, and then we're going to have a text input. And the input ID, how we refer to it down below, is going to be X lower and the label is going to be X lower limit. Okay. And now I'm going to copy this and create 4 inputs separated by commas. So this one is going to be X upper limit. This is going to be the Y lower limit, and this is going to be the Y upper limit. It's going to be X. And the label is what we actually see on the function. And the input ID is how we reference it down below in the server function. Okay, so now we have 4 beautiful text inputs. Now we need to create an action button. Input ID is going to be graph. And the label is create new graph. Great. Cool. And we're going to put that into a column. That's half the page. So half of the whole page is 12 is 6. We're going to stick all these into the column. We're going to create a new column. And on this column, we're going to have the data table output. And right below that, outside the column, we're going to have a plot output. So before I showed you how to create dynamic text output that responds to server functions. So similar to text outputs, you can have plot outputs, which display plots, and table outputs, which display information in tables. Okay, so what we want to do is table output, and we can specify output ID. And this is going to be called data. And down below, we're going to specify a plot output, and the output ID. So this is going to be graph button. So I want to call this output ID graph. Okay, now when we set a width. Okay, so now when we restart, notice that we don't see anything new. That's because these are dynamic outputs and only respond to changes in the inputs. Okay, so here, let's go through the body. We see all these display widgets displayed. We see a title here. We see text inputs. We see a button, all in this first column. In the second column, we see a table. Right now, it's empty, so we don't actually see anything in the table. And down below here, we are going to draw a plot. But again, the plot, there's nothing in the plot, so that's why we don't see it. But just because you don't see it doesn't mean it's not there. Okay, so now we're going to go here is, actually, sorry, I'm going to change these text inputs to numeric inputs. In numeric input, you have to specify a default value. So default value here is going to be 0, 10. Don't ask me why, these are just random values that I chose. Okay, so a numeric input is exactly the same as the text input, except it only takes in numbers. And I just specified default values for these input widgets. Okay, so now when we create new graph, when we hit this button, we want a blank plot to appear down here. So to create interactive app material, we have to write a server function. So we go down here to the server function and we observe event, and we want to observe the following event when we hit this graph button, referenced by the ID, referenced by the ID graph button. So we're going to type in graph button and type these curly braces. Okay, so in here we want output graph, the plot here, referenced by the output ID graph. We want to render plot. And inside this render plot function, it's kind of weird. You put the plotting function itself into here. So in here, we write the plotting function with all the parameters. And what it's going to do is it's going to send that plot to the output called graph here, and it's going to display whatever we want. So here we want a blank plot. So actually what I recommend doing first is going to your RStudio and looking at the plot here. First, let's type in the blank plot that we want to happen here. So we want x equals null, y equals null, and we want the limits. Let's just say the limits are 0 and 10. And that's it for now. And that creates the blank plot that we need. So now I'm going to copy this. Now I'm going to copy this into here. So when you're coding in R at our RStudio, it's always helpful to run your local functions and plots locally in RStudio first before trying to see how it works out on the app. Okay, great. So now when we create graph, it creates a new empty plot with x limits 0 to 10, y limits 0 to 10. But actually what we want to do is not just create any blank plot with limits 0 and 10. We want to make it with the limits that are specified by the inputs. So we can access the values inside these inputs by the input ID. So I'm going to make a new variable called xlow. And inside xlow, I'm going to put in the value of the x lower limit that the user specifies, which we can access by input xlow. Cool. And x high, specified by the input ID is x high. You can confirm above. It's y low and y high. Okay, great. And now instead of hard coding in the actual values of the limits that we want to put, we're gonna put in the variables. So I'm gonna say x low, x high, y low, y high. Great. And then when we create a new plot, it creates it based on the limits that we specify here. So if we want 234, it creates a new plot that's approximately of size 200 by 34. That's pretty cool. Okay, so now what we're going to do is be able to plot some points. And this uses a nifty function called the plot click function. So up here in the plot output, we're going to write plot click equals plot click. Click equals plot click. So now when we create a graph, notice that on this app, we have a little pointer here in which we can specify the points on the graph. Okay, so we go down here. We want this app to respond when we hit the graph. So we want to create an observe event that responds to plot click. And for now, I'm going to just print out the values of plot click x and I'm going to print out the values of y, and you'll see. Okay, so when I create a new graph, what I'm going to do is when I click this, it prints out the x and y coordinates of the points that I'm clicking on this graph. Cool. And now we want to render the point at this specific coordinate back onto the graph. Okay, so what we're going to do is points. So what I'm going to do is say x. I'm going to assign the x coordinate of the value of the mouse, the coordinate that I click to a variable called x, and then y to y. And then what I'm going to do is just type points y. Now when we create a new graph, I'm going to hit this. Oh, sorry. We're going to render that to the same plot. So output graph. We're going to render plot on these points. Okay, so now when I hit this point, and I click here, notice what happens. So unfortunately, it deleted my plot and just replaced it with a point. So actually what R does is it can only store one plot into this plot output at one time. So what it does is it replaced my old graph with this new graph that only has 1 point. So to get around this, to make it look like we're actually adding points to the existing graph, what we have to do is make a function that draws a graph and all the points every time we click the graph. So basically what we want to do, instead of hit points, we want to also plot this, right? We want to plot this and put the points on here. So this requires two things that we haven't really touched on before, creating functions and global variables. So in here, I created new variables called x low and y low, and x high and y high here locally. But actually, before I continue, I noticed that I am reaching the allotted time for this class. So if you schedule time for this class, so if you do have to go, I'd be sad if you left, but I understand if you have other commitments. So I want to thank you for coming to this course. If you want to continue learning this last bit, it's only going to take 10 to 15 more minutes. I'm going to continue now. Okay, so where are we? So in this observe event, when we created a graph, we created local variables called x low and x high, y low, y high, that represent the values from these inputs. But they're local variables, which means that they can only be accessed within this observe event. So which means that if we try to access these values inside the plot click, they won't work because it won't be recognized. So what we want to do is actually specify these variables outside of the functions as global variables. And global variables are variables that can be accessed from anywhere in the code instead of just inside the function. So I'm going to instantiate some global variables, and I'm going to initialize some random values to them. And then here what I'm going to do is I'm going to, instead of creating a local variable, I'm going to assign this value to the global variable called x low. And to assign a value to a global variable, instead of creating a local variable, you have to use double assignment operator. So now I can access these variables x low, x high, y low, y high down here in this other function that's outside this function. So now, as I was saying, I want to, I'm going to copy this in. I want to plot this graph, and then on top of that, plot the x value and the y values. So now we plot this. It works. We see that the points are overwritten. The points are overwritten onto this graph. Okay, but also, but now we run into another problem, which is that it only renders 1 point at a time, because it's only saving 1 point, the coordinates of 1 point at a time. So we also want to create a global variable called points, which is going to be a data frame of points. Data frame of points. For now, I'm going to say that's x. I'm just going to initialize a random point. Oops. Initialize a random point to 0, 0. Okay, great. And then now what we're going to do is, instead of just creating a variable x and y and plotting that point directly, we're going to actually save this point to the data frame, so that each time we click on the plot to create a new point, it initializes a new plot, plots all the existing points, and then plots the point that we just clicked. So it appears as if nothing changed and we just clicked the point. Okay, so so now every time we click this plot, we're going to save the x coordinate into variable called x, the y coordinate into variable called y, and what we're going to do is add these coordinates of this new point that we just clicked into the data called points. So I'm going to rewrite the variable called points, and inside it, I'm going to append a new row, which I can row bind the existing data frame and add a new row, which is vector x, y, right here. And now what I'm going to do, instead of plotting just x and y, I am going to plot, I'm going to plot all the coordinates of all the x values in this data frame called points. So points x, and then all the points for y. And then hopefully this should work. Let's see if I can get in the first try. Okay, cool. And now we have it here. And so now what this actually does is, so we're clicking a point on this graph, which sends the coordinates of that point to the input variable called plot click, which in this observe event, we extract the values of the coordinates of the point that we just clicked, and then we add that to our list of points here, and then we re-render the whole plot along with all the points in the existing data frame. And then finally, what we're going to do is we're going to render a data table specifying all the points that we just clicked. Okay, so notice the sequence of when we want to render this data table. So we want to render this data table initially. We don't have to put this in any observe event because it's not being outputted as a result of something. So when we click this button, this button should not be the reason why this data table shows up. It should just be there right at the start. So right up here, we're just going to put it right here as initialized, and we're going to put a data table into the output. It's referenced by the output ID called graph. No. It's referenced by the output ID called data. And we're going to render table, and we're going to render points, which is the data containing all the points. So now when we click, we see this data table rendered, but it hasn't updated because nothing told it to update. So actually, we want to also update this data table every time we click a point, which means we also, under the observe event function for plot click, not only do we want to output this graph, we want to also change the output of the data table, which is referenced by the output ID called data. So render table, and the data table containing all the points is in a variable called points, as we created up here. So now when we create a new graph, it displays all the points as well as the coordinates for all these points. And now your job in the workshop, if you decide to say this last little bit, is to create some more widgets that allow you to adjust some parameters of these points and the elements in this graph, such as the color or of the data.